Hello, everyone, and thank you for joining us for today's webinar, where we'll be focusing on dynamic secrets and beyond, how to enable modern privileged access management with Vault and Boundary. My name is Connor Beechnor, and I'll be your moderator for this session. And today I'm delighted to welcome Ricardo Romero, who's on our solutions engineering team here at HashiCorp, and he'll be your presenter today. In terms of housekeeping, if you do have any questions throughout the session, please ask them via the chat or by clicking on the Q&A button at the bottom of your screen. We'll then answer any of those questions at the end of the session. We also have a number of polls during today's webinar, so be sure to give your answers to those as we go. Just to let you know that this session is being recorded and we'll be able to share that along with the slides with you after today's session via email. Usually that takes about 48 hours. So with that, let's get started. Over to you, Ricardo.
All right, thank you so much, Connor, and thank you so much everyone for being here today. And so, as Connor said, my name is Ricardo Romero, and I'm a solutions engineer here at HashiCorp. And it is my absolute pleasure to be here today to talk to you a little bit about Vault and Boundary and how it can help us improve our security posture in terms of managing secrets and connecting to remote hosts. So as Connor said, if you have any questions, make sure to use the chat. Feel free to ask any questions, and we'll try to answer them as we finish the presentation. So before I begin, I wanted to get to know the audience a little bit better, just to set the stage for today. And if you can please help me out by answering a quick poll that is already here. So the question is, what are the biggest security threats in your organization? And we have decided to put some options here like password leakage, maybe loss of confidential information, maybe you have concerns about social engineering attacks and so on. So I'd appreciate if you could answer that real quick. We're gonna leave it just a few seconds so that we can see what's the biggest concern in terms of security for your organization here. I'm already starting to see some answers coming in. It's quite interesting. So I'll just leave it a few more seconds to see if we have some more answers coming in. Yeah, and I'm already starting to see that the the biggest concern that you may have is password or credential leakage. So I'm going to end the poll now, and thank you again for answering that question. And it is really interesting. So why I wanted to do this is because I wanted to start with this to help set the context for today's presentation. Because in terms of security, these threats that we showed in this poll are something that we can, I mean, it can affect really everyone. And I'm sure that you can relate to some, if not all of these risks. So we set out a survey last year in HashiCorp to ask a bunch of different companies, cloud leaders, exactly this, like what is your number one concern when it comes to adoption of cloud and cloud security in general? And when respondents came back, they said that the number one concern, like we're seeing right now, the number one concern that they have is actually having their credentials and secrets being exposed or leaked outside of the organization. So as we saw right now, and as we saw throughout this year, these numbers really caught our attention because, as you can see, this, especially password leakage, is a big issue that raises concern even more than phishing and social engineering attacks, which is also a big threat to organizations. And it is comparable to data theft, which, as we know, has tremendous impacts to companies in terms of regulatory or legal consequences, and also can have some very deep implications in terms of reputational impact, for example. And we also saw that these numbers were actually quite validated also last year because Verizon also published a report saying that 9 out of 10 breaches were caused by credentials being leaked or stolen. And to make matters worse, as you see, the occurrence of these kinds of situations has increased by almost 4 times in just the past 2 years, right? So that's something really take care of. And 3 out of 4 of those breaches had some sort of human element involved. So in general, we see that these are really interesting numbers, to be fair, that reflect a situation that pretty much affects any organization, every organization on the planet. And we know that in these kind of situations, it's not a matter of if that can happen to us, but when it will happen to us, right? Of course, if we don't have the effective security strategies in place, and in particular for credentials being stolen, because as we saw even in this little poll, this is the biggest concern in terms of causing breaches, right? So based on this, we at HashiCorp, we wanted to come up with a way to help organizations reduce their overall risk, especially when it comes to protecting those credentials, right, that can get leaked or stolen, as well as the applications that consume those credentials. So in order to provide this help, we realized that the best way to do this is by taking a holistic approach and really see the whole life cycle of these credentials and the access in general, instead of just focusing on one feature for one thing and so on. And so, as you know, securing applications at the moment of deployment on what we call day one is only the first step to managing the lifecycle of security. And it doesn't end there, right? Because on day two, we have the day-to-day operations, we have maintenance, we have different updates and changes that we do to our applications. And throughout that whole life cycle, these credentials face the risk of exposure, as we talked, until we eventually, retire those applications and credentials on what we call day N. So from our perspective, from our standpoint in HashiCorp, we have the HashiCorp Cloud Platform, which offers a suite of tools to help us overcome these challenges specifically. And as you probably may already know, we have Vault, which is our identity-based secret management tool that has some very advanced, very interesting capabilities for managing credentials and certificates and so on. Then we also have Boundary, which is focused on securing the interactions between human users and machines by providing a modern approach to PAM, which is privileged access management. And we also have Consul for securing the interactions between machines by implementing an identity-based network using Consul Service Mesh. So with all these tools, what we want to do is help organizations ensure that they have the systems in place to protect their digital environment, inspect their data sources for credentials that can get lost or stolen, and make sure that the connection between human users and systems is done in the most secure way possible. So now let's take a closer look at how we can leverage the capabilities of Vault and Boundary specifically to help reduce that overall risk, right? And for that, we'll take an example of an organization that starts from the very beginning, right? So we are in a sort of immature standpoint in terms of managing those secrets. Maybe they have secrets in many different places, locations, and data sources. So then we'll look at how we can take that first step to reducing that risk by moving all those secrets to a secure location and centralized. And we're going to do that using Vault. And then we'll see how we can further improve our security standpoint by implementing the advanced capabilities of dynamic secrets. And then in the end, we'll wrap it all up by bringing Boundary into the picture to streamline the workflow of human users accessing those resources in your IT infrastructure by consuming those secrets in a seamless way that are already managed by Vault. So let's see how that works. And we'll start with the challenge that most organizations have regarding their secrets, which, as we know from the beginning that we did this poll, the problem is that those credentials, those passwords are in many different places, right? Sometimes very insecure locations like Confluence pages or code repositories. And when we talk about the risk of exposure of these secrets and credentials, we see that it's not constant, right? It actually evolves over time and increases over time if we don't take the proper actions. Because maybe in the initial phases of, for example, application development, we have all these passwords and keys and other secrets, maybe in a single file or maybe in a single repo. But as time goes by, we see that those secrets tend to be shared among other team members or maybe even across different teams or parts of the organizations, Or maybe those repos were initially private and there's no problem, but then for some reason we have to make those repos public. And maybe even we have situations where employees have different copies of this code, different copies of these credentials, and they may have in some different locations, right? Like personal computers, personal repositories that can be all over the place, right? And what happens when they leave the company, of course. And this is challenging for organizations to manage all these secrets because, as I'm saying, they are in so many different places. They are sometimes the situation that happens is that our developers hard code these credentials in code repositories and they get sprawled across many different repos, or maybe they're shared in messaging platforms like Slack, which is actually quite common, honestly. And also, for example, in ticketing systems, so there are issues that we need to raise to other teams. And in order to provide the most context possible, sometimes we include, let's say, API keys or cloud credentials in our tickets. So as we see, uh, these secrets end up being in many different places within the organizations or even outside of it. And then on top of all that, all these secrets tend to be typically long-lived and they are rarely rotated. So with all these unmanaged secrets that are long-lived and are scattered across different places, we start to see how if they get compromised, they pose a very high risk to the overall security strategy of the company, of the organization. So now the question is, how do we address this problem? And the first step really is what we call discovery, right? So it's trying to figure out how many of these secrets we have out there. Because again, this is not a matter of if we have them, but actually it's a matter of finding out where they are and what kind of secrets we have exposed in our unsecure locations. And once we do that discovery process, then we can really start to focus on bringing them all together under a single centralized management solution so that we are making sure that they are actually managed. And then we can start to think about enforcing proper policies and security controls. So let's see how we do that, right? We know exactly that the first step we should do is discovery. And now the question is, okay, so how can I discover where those secrets are? And this is where HCP Vault Radar comes into play. So Radar enables administrators or other operators to scan the most commonly used data sources. And the results of these scans are presented in a dashboard like the one you're seeing right now in HCP. And the thing is, you get a prioritized overview of the issues that were discovered. And this prioritization, this severity ranking that we call is very important because as you can already tell, it allows you to prioritize which issues to triage and remediate first. And in this process, there are three key phases in terms of managing those unsecure secrets, which are detect, inventory, and engage. So the first step is detect, right? And as I said, Radar has the ability to scan many different data sources. We currently have support for over 18 data sources, including GitHub, Amazon S3, Slack, probably Jira or ServiceNow. And we'll continue to work on that, adding more data sources as we keep moving forward. Then we also have the ability to compare those discovered secrets to over 300 known patterns that a radar has. And so that helps eliminate secrets throughout different development workflows, for example, in pull requests and commits. And then it also includes deep scans to, for example, see throughout the Git history, or even it can help us detect if those secrets are still active or not, so we know which ones are the most critical to remediate. And so this allows us to identify different kinds of secrets. And that after that, we also have a post-processing check, for example, by evaluating the entropy, which is a different way or fancy way to say the randomness of what we discovered. And this helps us provide a higher degree of accuracy to eliminate those false positives, right? So then the next step in this process is inventory or also cataloging, the cataloging phase. And in this case, what Vault Radar helps us with is by providing some context about the discovered secret. So in this case, Radar tells us what type of credential it is that we discovered, who are the authors, what is the source, like where were they found, and what was the severity of the exposure, and even if, like I said, even if they're still active or not. Then we also have a remediation recommendation. And then it allows us also to check if those discovered secrets are already managed by Vault so that we can take the appropriate actions if needed. Then in the last part, we have the engage phase, which is basically handing off those discovered secrets and credentials to the appropriate owners of those. Maybe it's developers or any repo owner so that they can remediate the issues that they found in those environments. And for example, here we have pull request check, which basically allows Vault Radar to perform a scan against every pull request that is open and every commit also, for example. And then we can configure our version control system, which might be GitHub or Bitbucket, to block that pull request in the case we need to. So now we have a handle of the unsecure credentials and secrets, and also we have the remediate steps and the remediate plans to any issues that we found. And now we've done all this work, right? And we started to improve our security posture. We're already starting to move forward, but we don't want to go back to where we were, right? So what can we do to prevent those secrets, those credentials from falling out of sight again? And this is where the various integrations with Vault Radar come into play to help us prevent those credentials from leaking in the future. And so, in addition to supporting those over 18 different data sources that I talked about, Radar also integrates with common developer workflow tools, for example, Jira or Slack, to help us detect the remediation on to help us detect those secrets and provide a remediation step on an ongoing basis, right? So these integrations can be, for example, with a ticketing system, like I said, or an alerting system like Slack. And then we can help, by doing this, we can help organizations where they already are with the tools that they already have in place for engineering workflows or incident response workflows. So here, for example, Radar integrates with Slack to notify administrators in real time as soon as an unmanaged secret is detected. And here we have alerts that tell us all the details that I discussed. So what type of secret, where it was found. And then we also have integrations with other tools, for example, GitHub and Bitbucket to prevent secrets from being released out in the first place, right? So as I said, we have the example of a pull request. In this case, that pull request will trigger a scan for Radar. And if Radar detects that there are credentials or other kinds of secrets in that code, we can make sure that the merge is prevented until remediation takes place. Then Radar also can integrate with other tools, for example, Jira and ServiceNow, that can help us automate, like establish an automated ticketing workflow, right? So we can make sure that we not only have notifications of those secrets being discovered, but actually we can also ensure that the proper remediation actions are taking place, and we can have the whole process tracked in a ticketing system like we mentioned. Okay, so now we learned how to detect these unmanaged secrets, and we also know how not to go back to where we were. And this is really the first step that we have remediated, which is preventing more secrets to leak outside of the organization. So now the second step is how do we store and manage them? And ideally, you'd want to be using a centralized manager for secrets like Vault, for example, which can provide a lot of advanced capabilities for secret management and has compatibility and interaction with many different secrets engines. And one of the simplest one to use, one of the most widely used, maybe the one we can start with, is the KV secrets engine, which is key value, where we can store static credentials, right? So what we do is now that we have discovered those secrets in those unmanaged locations, we take them from those places, we delete them in that they were in those unmanaged locations, and we put them inside Vault, right? Inside the KV secrets engine, for example. And so now we are already starting to put in place some policies, governance, audit logs, and now we can even have permissions to limit the access for to those secrets for specific teams or specific users. And by doing that, we are already starting to put in place some security best practices and overall have better control and visibility over our credentials. Right, so now we're starting to see how little by little we're maturing in our journey to a better security standpoint. But as I said a minute ago, we're only using so far the KV secrets engine, which basically means this is not quite ideal yet, right? Because all these secrets are still static. And as I said before, they're usually long-lived. And if they're long-lived, they face the risk of eventual exposure, right? This is the situation that we discussed at the beginning. It's not a matter of if, but when it can happen, right? So this is where the need for dynamic secrets comes into play. And right now, I want to take a minute to talk about this. And so we know that static credentials pose a higher security risk to any organization. And these static credentials tend to be long-lived mainly because there's quite a bit amount of effort of significant operational burden when it comes to rotating them frequently, or just because operators or administrators just simply tend to forget about rotating them often, right? And since they are static, they tend to be shared among other users, other teams. And of course, this leads the organization to a higher risk of exposure because the longer these credentials live, the higher the probability that they can get leaked or exposed or stolen somehow. So when I think about this is like an analogy of having a house that you put out for rent, right? And every time you get a new guest, it's like you're handing out the keys to your place. And the only guarantee that you have is trusting them that they will give the keys back, right? But during that time that they have the keys, you don't really have any guarantee of them not making copies of their own and distributing those copies among friends, among family members. And what happens when those keys get lost or stolen, right? So if we think about this way, the only way we can guarantee that our house is actually secure is by changing the lock often, so that even if we have tons of keys outside, if I change the lock, it's no longer going to work, right? But if we think about this takes time, it takes effort, and in the end, that also translates to money, right? It's all the money that it takes to do that changing lock. And so in that sense, it's very similar to, sorry about that, it's very similar to the credentials of your digital infrastructure. So there are some kinds of secrets that take a lot of time and effort to rotate them, and in the end, that also means money. And so people don't really do it, right? Because it's quite difficult, it's quite burdensome, and so we tend to give them very long times to live. And again, as I said, this leads to an increase in our risk profile. So what's the solution basically? How do we reduce the risk of static credentials being exposed without having to go through that manual and difficult process of rotating them? And so as I said before, Vault has several secrets engines that have many advanced capabilities, and one of them is actually dynamic secrets. So I wanted to take a minute to talk about that exactly. And the core idea behind dynamic secrets is that they are generated on demand and they have a very specific time to live, which we can set up, after which they are basically revoked and useless. Which means these secrets don't really exist until we need it, right? And so we can start to see that there is a big contrast with static secrets, which are long-lived, and even if we actually rotate them, we might end up taking the time and effort and all the thing that costs to rotate them, and maybe probably we're not even using that secret actively, right? So that's a big difference. That's a big contrast to dynamic secrets, which are generated only on demand. So we make sure that we are managing only the things that we're actually using. And then we also have the ability to revoke them on demand. So with dynamic secrets, we have also that functionality to revoke them in a fine-tuned way, right? Because each secret is uniquely created on demand. So Vault helps us have complete visibility over what secret has each client. And this means, for example, if we have a set of machines in our digital infrastructure, and machine 42 got somehow compromised, then we can specifically revoke the credentials that that machine had, and that can help us reduce the blast radius of that action to only that specific revocation, which helps us prevent full service outages that, for example, might occur if dozens or at least tens of machines are sharing the same secret and that secret gets compromised. So if we revoke that, we face the risk of basically taking down the whole service, right? And we also have with dynamic secrets a very broad support, so we can it can help Vault connect to many different applications and systems. And I actually wanted to take a minute to see in detail what these support for dynamic secrets have within Vault. And so the first one is databases. And what we do here is uh, Vault generates dynamic credentials based on some configured roles that we set at the beginning. And it has the ability to connect to many different databases. For example, we have Postgres, we have MySQL, we have MongoDB, and many, many others. And the way this works is Vault talks to that database with a private root level credential, and it creates new usernames and passwords on demand again. And so by doing this, our applications and services that needs access to those databases no longer need the hard-coded credentials that is actually quite a common practice, and they end up being in some .env files that might end up being pushed to GitHub, for example. So in this case, we remove that risk, we remove all that, and instead what we do is we tell those applications to talk to Vault, and they request those credentials from Vault. And the leasing mechanism that has makes it easy to roll out those keys every time these applications need them, right? Then we also have integration with the major cloud service providers like AWS, Azure, GCP, and others. And in this case, Vault helps us easily create and manage dynamic credentials for any user that might need access to those platforms. We also have the LDAP secrets engine, which provides management for LDAP credentials, as well as the dynamic creation of those credentials. And it can integrate with different implementations of the version 3 of LDAP. So we have OpenLDAP, we have Active Directory, and IBM RACF. And then we also have certificates. And in this case, Vault can be used as a signing intermediary to generate certificates that can be valid for even just a few minutes. And this is quite interesting because if you know how the whole life cycle of generating and creating those certificates is actually quite burdensome and it takes a lot of time. And in the case of SSH in particular, the common denominator, so the common practice here is that usually you have a single key that is shared between a large number of machines so that you can SSH into them. Whereas with Vault, we can prevent this from happening because you can generate unique credentials for each client every time we need them, so on demand, basically. And as I said, the case of certificate is particularly interesting because generating them is usually very time consuming. And operators, from the operator point of view, we tend to give them a very long time to live. And we end up having certificates that sometimes are valid for years, right? And they're just flying around in plain text. And if you think about it, there's not a clear strategy on how to revoke that situation, how to revoke those secrets, right? So by enabling the SSH and PKI secrets engines, we can use Vault as a signing authority and use a public key approach, which reduces the time to generate them. And it actually takes out a lot of steps like requesting for a signature and all that it takes a lot of time. So we can start to see how we improve our security posture. And we see how we have matured in terms of our security by first discovering, right, and managing their different credentials that might have been in different locations. And then we saw how we can further reduce that risk of exposure by implementing the different advanced capabilities of dynamic secrets, which is what we talked about right now. So now let's take a look at how Boundary can step in here to integrate with Vault to simplify and streamline the user experience of connecting to a private resource. Like I said, maybe it's SSH into a VM in AWS and so on. So here I wanted to take a minute to ask another poll. And in this case, I wanted to see a little bit of how is your current strategy when it comes to accessing to those remote assets that are in the cloud. So maybe you're using probably a VPN, you're using different combinations of Bastion hosts, or probably you're even using Boundary already. So I wanted to take a few seconds here to see what's the current situation here. So I'm already starting to see some answers roll in, and I'm seeing that actually the most widely used strategy is using a VPN, right? So we'll leave it just a few more seconds to see if we can have a bit more answers running in. Okay, so I think we can end it there for now. And this is already quite interesting because, as I said, using a VPN or Bastion host has been by far the traditional way of accessing our remote assets, right? And again, this is the most familiar workflow with VPNs. And the problem here is that it's really complicated to by using these tools, it's really complicated to enforce access control in a setup like this, right? So I wanted to take a minute to see how a traditional workflow using a VPN is. And so it all starts with the end user that might be, for example, a Kubernetes administrator or a developer. And the first step they do is basically log into a VPN, which is it's a very familiar experience. It's a nice experience. All of us know how to log into a VPN. And the problem here, as I said, it's difficult to have an access control here in place because once we log into that VPN, we basically have access to all the machines that are in that network. And so the next step is the user usually has to go and look up for the IP that they need. In this case, let's say we are an application developer and we need to connect to an Ubuntu machine. And so we go to another place, maybe it's another terminal, maybe it's a different application to look up those IP addresses. Sometimes it might be even a spreadsheet or a Google Doc, right? And then what we do is ask for the needed credentials to connect to that Ubuntu machine in this case. And right now, I'm assuming that already we have some good security practices in place. So we're using a centralized location like Vault for those credentials. And so we have three different steps so far, right? We log into that VPN, then we must look up the IP address for that machine or that resource that we need to connect to. And then we look up the different credentials for that. In this case, let's say we're going to SSH into that machine, so we need an SSH key, right? And so we have this number of different steps. And then once we have all that, then we connect to our SSH terminal, right? And then we have finally access to our remote host. So as you see, it has a number of different steps, can be 4 or 5, depending on the configuration that you might have. And the problem here is that there's a lot of manual effort that goes into doing a routine operations like connecting to a remote server. You have to go and look up the IP manually, have to connect to Vault and manually restore those credentials. And last but not least, then you take out your SSH terminal and then you log into that machine. Right? So now let's take a look at how we can simplify this whole process to Boundary, with Boundary, I'm sorry. And so the first thing we do, and from the user perspective, this is again a very familiar thing, is logging into Boundary, right? And here I wanted to say that Boundary also provides the option to use many different identity providers such as OIDC or LDAP, so we can already configure, for example, Azure Entra ID or Okta, depending on the provider that you might already be using. And so maybe we have already a ton of applications that use single sign-on, and so Boundary is not going to be any different. So that's already a very familiar workflow. And then once we log into Boundary, we can already see that we no longer have access to the full network of resources. So here we can already start to enforce role-based access control, right? So depending on what is my role as a user, maybe I'm the Kubernetes administrator, maybe I'm a database administrator, or I'm a Java developer. I might need access to different resources. So in this case, I only have access to AKS or the Ubuntu machine or the Postgres database. So let's say now we connect that Linux host and I have a list. So I connect to that host. And then what's gonna happen is Boundary is going to automatically ask to vault for those credentials. So they are already centrally managed. They are already with dynamic secret capabilities. And so now Boundary does all the retrieving of those credentials. And then those credentials are handed back to me. And then I, as an administrator, then again, I open the SSH terminal, for example, and then I log in. So as you can see here, we have basically reduced the amount of steps from 5 to basically 3. And we can already start to see how this is more streamlined, this is simpler, but so this is already quite interesting, right? But is it possible that we can do it even more streamlined, even simpler from the perspective of a user, and also more secure, right? Because we've seen that so far the end user still has to manually handle those SSH keys or those different credentials. And we again are facing the risk of exposure or sharing those credentials. So I wanted to introduce you to a feature from Boundary called credential injection. So let's see how that works in real life. And let's go through the steps one more time. So we log in with Boundary. Again, this might be using Okta, for example. Then the user selects the targets that they have access to, because they don't have access to all the targets, but only the one that are allowed by the role. And then we select that Linux host. And what's going to happen here is instead of giving back the credentials to the user, um, Boundary is going to automatically inject those credentials into that remote host so that we don't have any opportunity to expose those credentials, right? So um, we're basically eliminating that risk. And this process is now more streamlined because the user did not have to handle those credentials. It is also a completely passwordless workflow. And as I said, it's just more secure because the user doesn't have any visibility on those secrets that were involved. So we basically eliminate the risk of credentials being exposed. And so yeah, the credentials are automatically injected, and that's how a user can log in. And now I'd like to present to you a new feature that's currently being a work in progress, and it's currently going through a beta phase at the moment, and that is called transparent sessions. And the motivation here is to improve even further that user experience to make it even more seamless, more simple, of course, without compromising our security posture. And so the goal here is to allow the end user to have that remote access without having to click anywhere. So once we log into Boundary, that's all the interaction we need basically to Boundary. And so things happen in the background basically. And I'd like to show you how this looks. So again, the user logs in to Boundary, and that's basically it, right? We don't have to do any more interactions with Boundary. Everything happens in the background, the brokering of credentials, the access control enforcement, and everything we talked about is completely taken care of and completely transparent to the user. So now what we do is just open our connection tool. So maybe it's a PuTTY client or an RDP client, or like we have been saying so far, maybe it's an SSH terminal. And that's it. I just do SSH to the name of my target, and I get in because the system is already aware that we have access to Boundary. And so this is what transparent session looks like, and it's currently in beta phase. And we're targeting the release of this feature very, very soon. So actually stay tuned for any update or future events in the upcoming days. So so far, sorry, so far we've talked about the different capabilities that Vault and Boundary enable us to do. But now let's take one step further and think about compliance, right? Because life goes on. This user ended that session and did all the configuration they needed. They created all the different resources that they needed. But the life cycle of this session is still an important problem for Boundary, right? Right? Because like most organizations, maybe we have regulatory rules that we need to follow. And so Boundary has something called session recordings. And this is what I want to show you now. And there are situations, where audit logs are just not good enough. So audit logs in Boundary provide us information about what user accessed and what system, but it doesn't really tell us much about what they did when they accessed those systems, right? So with session recordings, we have the ability to get that context of what they did and at what moment. And if there was some kind of breach, then the administrators and the different security folks can go into that session recording and analyze what happened. So, like, for example, what time did they log in? What did they do? Did they upload things? Did they download things? Did they create things? And we can really start to figure out a plan to remediate any potential breach if that was the case. So this way we can start to standardize the adherence to the regulations and compliance. And really from a human perspective, right? Because in the end, we're talking about humans. From the human perspective, on top of that, the fact that users know that these sessions are being recorded, uh, just maybe make them think twice, right? Before doing anything that might end up compromising the security posture of the organization. So we can see that by enabling session recordings, we have actually multiple layers of security that are being put in place. And now I wanted to show you a quick demo of all the different features that we have talked about. And so let's see how that looks. Here I wanted to present to you basically the HashiCorp Cloud Platform. And as we see, we have like a catalog of all the different products. So I'm gonna head out to Vault Radar. And here's that prioritized view that I talked about, right? We have the different secrets that were discovered, what's the severity of their exposure, where were they found, also what categories do they belong to, what authors are involved in those secrets. And what I'm going to show you now is how we can enable those different integrations. So for example, if I go over to Slack here and I have this integration connection that I can enable. And what I'm going to get is a notification from Slack in case some secret is discovered, right? Which we can see here. It was a private key. And Slack will tell me, if I go over to Slack, it will tell me all the different details that were related to that discovery, right? It can tell me what kind of secret was it, who's the owner. And if I go over to the page in HCP Vault Radar, I can see that the severity is high, for example. I have what kind of secret was discovered and also where it was. And in this case, it was a GitHub repository, and I know that the culprit here was an SSH key. So we can identify exactly what kind of secret, where it was found. And then once we do this, we want to start thinking about managing those secrets that we discovered, right? So I can also put that this was marked as triage, so we can start to remediate that issue. And like I said, now that we have discovered all these different secrets, we can start to manage them in a centralized location, in this case using Vault. So I'm gonna head over to Vault here to show you how that looks. And if we go to HCP Vault, then we have our cluster running here. And if we launch that UI, we'll see that those secrets are in our different locations. So we see here the list of the secrets engines that we have. And in this case, we're seeing the KV secret, the static one, right? And so we can see that already that key that was discovered is managed here. And again, as I said, we have the ability to improve that security by enabling the dynamic secrets capabilities of Vault. So instead of using the KV, we're going to use the SSH secrets engine. And now I'm here in Boundary, and I can show you how we have all the different targets, and in this case is the credential store. So we're telling here Boundary how to communicate to Vault, and we're showing here that this is the place where Boundary should take those credentials from, right? So now let's take a look at those targets. And again, assuming it was the Linux machine that we want to connect to, here we know that the credentials to connect to SSH are taken from that credential library. So now if we see that from the perspective of the user, you know, we just logged in, we have a list of all the different targets that we can connect to because we're enforcing RBAC, and then we just do SSH right away. So from the operator's perspective, we do some configurations here. In this case, we're creating some file. And now, again, life goes on and we continue with our day-to-day operations. But in case we need to adhere to some compliance rules or regulations, we also have here the recording of that session. And we can see that anything that happened in that session, like for example, creating the different files or all the different configurations that we made, are stored here in Boundary, and we can look them right after it was created. As you saw here, the session ended just a few seconds ago, and we already have access to those recordings. And that's basically what I wanted to talk to you about right now. And if we move, yeah. So this was like a wide overview of what we of all the different things that Vault and Boundary enable us to do. And if you want to learn more, make sure to go over to our developer page where we have different tutorials or different documentations for all these tools. And also, if you want to take your certifications exam in Vault and Terraform and Consul, you can go over there. And if you want to try those things out, you can sign up for free in the HashiCorp Cloud platform. So I hope this was useful for you to understand how using Vault and Boundary can really enable us to reduce that risk when it comes to managing credentials, when it comes to accessing those remote machines. And that's it. I want to thank you so much for your attention. And now I pass it over to Connor. Maybe we have some questions.
Thanks, Ricardo. Great session. Really enjoyed the demo at the end as well. And just the one question that we've got so far says someone in the audience says, I'm interested in Boundary, but I don't have the in-house capabilities or knowledge in-house to get this into production. What are your recommendations on how to get started?
Sure. So I could say maybe here there are two things that you can very, very quickly start doing. The first one is maybe start by using the developer version of these tools, specifically Boundary. If you download the Boundary binary, you only run the command boundary dev, and that's it. You have already a dev server running in your local machine. And then there's also the opportunity for you to, like I said, you can sign up for free in the HashiCorp Cloud platform, and you can already start. It's actually quite easy to deploy a Boundary server, a Boundary cluster, actually, the whole production version of Boundary cluster. And you can do it super easily in the HashiCorp Cloud platform. So you can start maybe discovering how it works, maybe implementing some of these features in your own workflows and so on. I don't know if that may answer the question more or less.
Yeah, absolutely. And as you say, I think developer.hashicorp.com is a great place to get started. There's a whole host of step-by-step tutorials on there where you can go through at your own pace, really starting from downloading the community versions all the way through to some quite complex use cases. So that's a great place to start if you're thinking about adopting any of the tools, including Boundary.
Exactly. Thank you.
So with that, it doesn't look like we have any other questions. So with that, we'll conclude today's webinar. A big thanks to you, Ricardo, for the excellent presentation and the demo, and to everyone in the audience for joining us. If you found this session valuable, then you might also be interested in HashiConf, which is our global conference taking place next week in Boston, but we're also streaming it virtually. You can watch all of the keynotes, you can select some technical sessions, all for free. We'll share a link in the chat to that now, so you can add that live stream date to your calendar. Just a reminder that this session and this webinar was recorded, and we'll share that as well as all of the slides that you've seen today via email within the next 48 hours. So with that, I hope you enjoyed today's session. Thank you so much for joining us, and we look forward to seeing you next time. Thanks, everyone.
Thank you.